of the most fascinating things about electronics is how you can turn an analog voltage into a digital number. This is exactly what the Arduino analog to digital converter, or ADC, does. An old-fashioned incandescent light bulb is easy to understand. Give it more power and the filament gets hotter and the light gets brighter. But with an Arduino, we control the LED using PWM, pulse width modulation. The LED is actually switches on and off hundreds of times per second. It happens so fast that your eyes cannot see the individual flashes. If the LED is on for only 20% of each PWM cycle, it looks dim. At 50%, it looks brighter. At 75%, it is brighter still. So let's go inside the Arduino and wire up a potentiometer so we can see exactly how that analog voltage becomes a number and how that number can control the brightness of a LED. Voltage is analog. You can think of an analog voltage like a real number. A potentiometer is basically a variable resistor with 3 terminals. One goes to 5 volts, one goes to ground, one goes to an analog input on the Arduino. We will use A0 in this example. A0 is one of the 6 analog input pins on the Arduino card. As I turn the knob, the voltage on A0 changes continuously between 0 and 5 volts. That is an analog signal. The potentiometer itself does not convert analog into digital. It simply changes the voltage going into A0. The ADC inside the Arduino's microcontroller is an analog to digital converter, or ADC. Its job is to take the analog voltage on A0 and turn it into a digital number. On the classic Arduino Uno, the ADC produces a 10-bit number. ADC is approximately 1023 divided by 5 times the voltage. So if the voltage is 2.25, this is approximately 511.5. The ADC will truncate that, round it off. So the ADC will be reading about 512. Okay, and it chops off the decimal part to give us an integer. Remember, we need discrete values, not analog. So when I turn this potentiometer, I'm changing the physical voltage. The ADC measures that voltage and converts it into a number that our C program can use. Now let's use that number to control a LED. The potentiometer is not wired directly to the LED. That's the counterintuitive part, but it's interesting. At first it's not obvious. You might wonder, how can turning this knob change the brightness of a LED that isn't connected to it? Well, here's how. The potentiometer changes the voltage going to A0. The ADC inside the microcontroller converts that analog voltage into a digital number. Our C code reads that number and uses it to control pin D9. D9 goes to the LED, the resistor in the LED. When I turn the potentiometer down, the number gets smaller and the LED gets dimmer. When I turn it up, the number gets larger and the LED gets brighter. It's blinking faster, right? The voltage goes up, the microprocessor makes a larger digital number, the LED flashes faster. But how does D9 control brightness? D9 is a PWM capable pin. PWM stands for pulse width modulation. The Arduino is not actually sending a continuously varying analog voltage from D9. Instead, D9 switches very rapidly between 0 volts and 5 volts. The LED is literally turning fully on and fully off very rapidly. Your eye cannot see that, so all together that speed of turning on and off is what makes it seem brighter or dimmer. For example, if it's on half the time and off half the time, the LED appears roughly half as bright. That's called a 50% duty cycle. 25%, the pulse is only on for 1/4 of each cycle. At 75%, it is on for most of each cycle. The LED switches on and off so quickly that our eyes don't normally see the individual pulses. We just see the LED become brighter or dimmer. Okay, that's it. Look in the description for the code and a link to the Tinkercad so you can wire it up yourself on the Arduino.
The same. I made enough for